Welcome back to the deep dive. So I want you to picture a massive logistics warehouse. The air is just humming, and the pressure's on.
Pretty constant.
Every movement has to be fast, precise. But when things go wrong in that kind of environment, they go wrong fast. And we're talking about the sound no warehouse manager ever wants to hear.
That awful bone-jarring crash of a fully loaded forklift tipping over.
Exactly.
And, you know, that sound, it represents a massive crisis, not just some simple accident. The speed demanded by, say, last-mile delivery has pushed that operational tempo way, way up.
It's escalating the risk profile.
Totally. And if we look at the data from OSHA, the Occupational Safety and Health Administration, they confirm it. Tip-overs are responsible for a really high percentage of severe injuries and even fatalities.
And the cost is just staggering. I mean, we always think of the human cost first, which is, of course, paramount, but for the business...
The numbers are eye-watering.
Right. The average cost of a severe forklift incident, once you factor in downtime, repairs, lost inventory, legal liability, it can easily top $250,000.
That's before your insurance premiums go through the roof. It's just this perfect storm of human and mechanical factors pushed right to the brink. Operators going too fast, loads that are too high, hitting one little crack in the floor.
The stress is constant. So our mission today is to do a deep dive into the specific technology that's fighting back against this. And it's fighting back at machine speed.
Edge AI.
Edge AI. We're going to explore exactly how this intelligence lives right there on the shop floor, how it predicts and, physically prevents these catastrophic failures before that tipping point is even reached.
So let's start with the core concept, right? Most people know cloud computing, where all the powerful AI algorithms live on some remote server.
In a giant data center somewhere.
Exactly. But AI Edge artificial intelligence is different. It puts those complex algorithms directly onto the device, in this case, right onto the forklift itself. The processing is all local.
And that localization, that's the whole game right there. That's the key.
It's everything.
Because if the forklift has to send data, the tilt angle, speed, weight, all the way up to the cloud, wait for the AI to analyze it, and then get the instruction back down.
The moment is gone.
Those fractions of a second are gone. That latency, it just kills you when you're rounding a corner at speed.
Exactly. Latency is safety's enemy here. Localized processing means real-time analysis, which means immediate action. These edge AI systems, they have sophisticated sensor arrays measuring everything.
So tilt angle, speed.
Yep, tilt angle, vehicle speed, the precise load weight, and the calculated center of gravity, all in real time.
Okay, but isn't that putting all your eggs in one basket? I mean, if that sophisticated local system fails, isn't that maybe worse than relying on a big, redundant cloud system?
That's a very fair question. And it really speaks to how robust these systems have to be. They're purpose-built, ruggedized for high vibration, high impact environments.
So they're tough.
They have to be. And because the AI runs the safety-critical stuff locally, the core prediction and intervention capability is always there, even if you lose network connectivity. The AI basically turns the forklift into a genuinely smart machine that makes decisions based on its own immediate reality.
Okay, so when that decision needs to be made, say, mid-turn, how does the AI actually command the machine? Is it just flashing a light at the operator?
The buzzer sound?
No, it goes much deeper than a simple alert. If the system detects a dangerous tipping angle or an unsafe speed, the AI sends a real-time command over the vehicle's internal network.
The CAN bus, right?
The CAN bus, exactly. It tells the hydraulic systems and the throttle what to do. It can achieve an instantaneous deceleration or a correctional movement before the operator even has time to process the danger.
Wow. So that instant intervention where the AI is basically overriding the operator's input for, what, half a second?
Maybe even less. That completely changes the safety equation. Okay, let's unpack how the system moves beyond just reacting and actually starts to foresee a disaster. You mentioned 5 core predictive capabilities.
Yes. The first one, and this is kind of the foundational layer, is real-time monitoring of tilt and speed. The sensors are constantly feeding data into the edge AI.
Just a constant stream.
A constant stream. So if the forklift is moving too fast or getting close to that tipping threshold, especially in a turn or on a rough surface, the AI system flags that risk instantly. And that's where the active intervention happens.
It slows the vehicle down automatically.
Right. It pulls it back from the edge of stability.
Okay, so the second function focuses on the cargo itself, load and center of gravity adjustment.
Yes. Because it's not just about how fast you're moving. It's the physics of what you're carrying.
Right.
The AI is constantly running these complex calculations on weight distribution and where the load is placed, both vertically and horizontally. If it calculates that the load is too high or too heavy, or, and this is critical, improperly balanced for the speed,
It steps in.
it steps in. It might instantly reduce the maximum speed the operator can use, or it'll send an urgent notification to stop and reposition the cargo. It's preventing the operator from accidentally violating the laws of physics.
Okay, function 3 takes us away from driving behavior and more into the health of the machine itself.
That's predictive maintenance. We know tip-overs aren't always because of the operator. Sometimes it's a mechanical failure.
Like a brake seizing up on one side?
A brake seizing or severely worn-out suspension parts, things that cause instability. The Edge AI is continuously monitoring the machine's performance vibration levels, temperature, hydraulic pressure, to spot these tiny mechanical issues before they can ever cause an accident.
That feels like moving from reactive to truly proactive safety. So function 4 accounts for the messy reality of the shop floor. Dynamic safety protocols.
Exactly. Warehouses aren't perfect racetracks. They have ramps, tight corners, loading docks,
Uneven surfaces.
all of it. The AI adapts its safety rules based on the environment, often using GPS. So the system might have a standard speed limit of, say, 10 miles per hour.
Right.
But when the GPS shows the forklift is entering a known narrow aisle or approaching a ramp, the AI can automatically lower that safe speed to 5 and turn on extra stability features. It's creating a dynamic safety bubble around the vehicle.
And finally, function 5 is the human element, which, to me, this is where the lasting impact is really made. Operator assistance and training.
Yeah, this is where it gets really interesting.
The machine isn't just intervening, it's teaching.
Precisely. Beyond the immediate alerts, the Edge AI records and learns the specific behavior patterns of each individual operator over time.
So it knows my driving style.
It knows if you consistently brake too hard or if you always take that one corner a little too fast. The system aggregates all that data to offer personalized feedback and training insights. It helps the operator actually improve their driving and reduce their long-term risk.
So we've established it saves lives.
Yeah.
Immediately. But what does all this mean for the business ledger? If I'm running a major logistics operation, what's the actual ROI here?
The ROI is, well, it's pretty compelling because it hits 3 major financial levers all at once. First, you've got that direct safety dividend,
Fewer accidents?
a dramatic reduction in catastrophic accidents. That means lower insurance premiums and a lower total cost of ownership for the whole fleet, since your repair costs just plummet.
And I have to imagine the system's insights lead to huge gains in operational efficiency, too.
Absolutely. Think about optimal speed. Normally, managers have to set these really conservative speed limits across the whole facility to account for the worst-case scenarios.
To be safe.
Right. But with Edge AI, forklifts can operate at their actual optimal safe speed, which maximizes throughput without ever compromising that safety.
And the predictive maintenance, that minimizes unexpected shutdowns, right? If the system tells you a hydraulic hose is about to fail, you schedule that repair during planned downtime.
Exactly. Not when the machine is critically needed in the middle of a shift. We see big improvements in metrics like mean time between failure, which means your fleet is just more reliable.
Plus all that data.
A treasure trove of data. Not just on accidents, but on every maneuver, every load, every environmental variable. Management can use that to optimize routes, improve warehouse layouts, and standardize best practices across the whole operation.
So looking ahead, we're seeing this incredible prediction and prevention now. But where does this technology go in the next few years?
I think we're really only at the beginning of true machine learning integration here. As we move forward, these systems will learn from every single forklift operation across a company's entire global fleet.
Wow.
They'll constantly enhance their predictive accuracy by analyzing millions of operational hours. Imagine an AI that ends up understanding the stability limits of a vehicle even better than its original designers.
That really shifts the paradigm. It's not a local safety officer anymore. It's a global, constantly learning safety network.
Yes, and we'll see it integrated seamlessly with everything else. Autonomous vehicles, warehouse management systems. The Edge AI on the forklift won't just be talking to the operator, it'll be talking to the automation systems, optimizing traffic flow for the entire ecosystem.
It's an incredible transformation. Edge AI is it's completely redefining safety standards in logistics. It's providing that instant data analysis and immediate physical adjustment, turning these forklifts from simple tools into genuinely smart, self-correcting machines.
It is, and this rapid evolution forces us to think about the changing role of the human operator. I mean, since the AI is constantly vigilant, giving personalized feedback and automatically adjusting things when there's danger, the very definition of an expert forklift operator is changing.
That's a great point.
So it raises a question for you, the listener, to think about. How will this blend of constant machine vigilance and personalized data transform the required skills, the training requirements for human operators in the future? When the machine is guiding your technique every single second, what new skills must the human bring to the table to stay valuable? That's the high-performance question we'll leave you with today.